here's my lab report for this week. Tuesday, well, we got back on Monday, and I still can't really remember what we did on Monday. I remembered yesterday for a second, but I forgot.
Some days are like that. Work hangover. So we got back from Mexico on Saturday at about 8:30 p.m., 9 p.m. Something like that. So we unpacked on Monday.
Yeah.
I don't remember what else. Something.
So Tuesday, we went flying back here around the lagoon and the marker, and started working on my poster because we're having a symposium thing on Friday. We're presenting, so you'll
Where's
see
the symposium?
here, like in the hallways actually.
Yeah, you should join us.
Cool.
You'll see the other RU students. There's 6 of us. So
You're all going to be here?
Mel has her own student as well. She's doing chemistry. They're all doing water quality on Mexico. So
Do you know what time on Friday?
No.
Yeah, that'd be fun to go to.
Yeah.
We'll send an announcement.
Check that out. Yeah. So I started that Tuesday, and then continued working on my poster on Wednesday. Oh, and then Earl was showing us the rate code on Pix4D. So one of our sites, should have included the picture actually of how bad it looked. But there was the point cloud was just, there's like a wrong picture that was taken, so you could see the area, but then there's like another picture going that way across. So
A couple of like overlapping planes, like the normal ground plane, and then like a whole other bad partial forest reconstruction.
So then Earl was showing us how to just delete pictures.
Yeah.
So, but we didn't really finish our work.
So yeah, we tried to run it on this machine, and this machine only has 4 cores, so it was taking a long time. I ran it at home last night, but I guess I wasn't logged in or something, because it only had me logged in as like the Pix4D discovery, so I couldn't save the results. So I did that whole run, and it took a long time. So I just started it before I came in. I just discovered that this morning. So
Did you see the results? Did it work?
I didn't.
Oh.
It was hard. It was hard to tell from the point cloud.
Okay.
But yeah, I closed it down before I got a good look at it, because I thought, I'll just bring the point cloud and cloud compare, and then it was gone. So that's a bummer.
Yeah.
I don't know of a good way to fix that. Like if you're logged in on the wrong way, it just totally didn't write out the results. So yeah. Oh well.
Earl also recorded when he was showing us, so I'm not sure what's stored, but if you're interested in looking at what he did, it's somewhere here.
Yeah, for some of those things that are like one-offs, maybe we'll come up with like a tutorial system, something like, here's how you do this or here's how you do that, and they don't have to be,
And then we started post-processing for RTK units, or RTK clips. And then that's what I was doing right now, and where I got some weird numbers, like really high, like they were really off. So we'll try something else. It was just one site though, that was really weird, but the Cenote, like how the site, you just can't really see this type of so I guess whatever later.
So that was like the 26th of June. What was the date on that one? Okay. How many more days worth of data do we have to go through?
A lot. That's only in the beginning.
Okay. Are they going faster now that Pix4D isn't running in the background? Maybe not.
No, the well field took a long time. I think just maybe because I was there for 2 hours.
Long record, yeah.
I did that yesterday. I noticed it took a while, but I got the unit now, so.
Okay.
I guess.
It did occur to me on the drive in this morning that we have the laptop that we took down to Mexico. So if you want to use that, you should be able to do all the post processing on that. So maybe are you in town over the weekend? At home?
No,
Yeah.
I'll be not. But I could still.
You can do it at home?
Yeah.
Okay. Yeah, because it's just kind of like setting one up, hitting go. You can come back and set it up and hit go.
Yeah.
Okay. We'll see how much we can get through today. It'd be great to try to get them finished today, but if there's a little bit of overlap, we can.
If that's all I do today, I probably could.
Okay.
But
Yeah, let's focus on that. Let's try to get
Okay.
it cranked out and done. I'm going to be working on the map today.
Okay.
For one.
Cool. And then yesterday, Lily and I took busy to be out for another flight, and then something went wrong. Sadly, unfortunately. We flew a mission on tower. It was going to waypoint 6. I think there are 18 waypoints, and I just see it start falling from the sky.
Just randomly started falling.
Yeah, it just and it fell into the lagoon, but luckily, it was like on the edge. I was able to grab it. I grabbed it by the propellers. That's the only thing that you can see.
Did you get a look at it?
Yeah.
So maybe because one of the propellers was actually loose.
Yeah, it was actually an interesting exercise in diagnosing. So we looked at the pictures and we figured out which way the head was. So we knew the head was on the left side.
Yeah.
And so based on this image, which was the first image that it took when it started to go south, you could tell that it kicked out. We figured out it was the back right or back left?
Back right.
Back right. Yeah. So if it's flying this way and the back right propeller kicks out, then it goes here. And you can tell from the sky angle that that's the one that failed first. At least that's our guess. So, yeah. And we looked at it and it was loose. I was going to ask you, do you know, did we even take the propellers off between this day and the previous day? We didn't. So that's interesting. Because that means we flew a full mission on it the previous day and it was fine.
Yeah.
So that's weird.
Well, we didn't fly on Wednesday.
But we never took the propellers off between
No.
the differences, right? So we flew something, went back out and flew it again.
Because they self-tighten.
We're supposed to self-tighten, yeah. Yeah. But it was definitely, like, you could tell the propeller was, like, that far off of the tight. So, mystery.
Yeah. Lost the leg. Rubber pieces that are attached to the leg. Propellers are broken, and a lot of damages. The camera was over there, which is on there too.
Yeah, it kind of had a blue light on when they brought it back in. So we'll find out soon whether. But GoPros are pretty hardy, so. And we have one spare. That's the Labs and I own one, so we can still
What
fly.
happens if you damage property on the
Nothing.
lab? Okay.
Pretty much, yeah. It's just a thing.
Okay. Well, then I continued working on the RTK post stuff yesterday. So that's about it. Oh, and then Thomas showed me. Well, no, that was on Wednesday. Actually. A map that we could use for my poster. I could probably show you that. Of the sites and the field sites that we went to in Mexico. So.
Do you make the map? And is it like from Google Earth?
Where's the map?
So, yeah, it's going to be, we're going to be making it in ArcGIS.
Okay.
So, yeah, Lily and I are kind of helping her put it together. So we've downloaded the terrain layers. If we need any Earth imagery, we'll just get that from Arc. And then population data for 1990, 2000, all the way up to projected stuff for 2020. So actually, I just looked at that last night, and I'll show you that after the meeting. It looks okay. We'll have to figure out how we want to display it, but it's coming along okay.
I've been working on making maps in Illustrator.
Oh.
It's like tracing Google Earth images.
Okay.
Pieces.
Oh, okay. Yeah, once you're using Arc, Illustrator looks beautiful.
Yeah.
Not super well designed for spatial data. A lot of legwork.
Yeah, it was time consuming, but it looks nice. It does.
Yeah. So when we make maps in geography, ArcGIS is kind of the main GIS software. It makes maps that are pretty good. A lot of people use those for publication. But professional cartographers will use Adobe Illustrator as a second round to clean up the images and make them look really, really nice.
And I want all my diagrams to be black and white in my thesis, so people can just print them. Don't have to worry about color printing.
Yeah, it's smart.
So Illustrator makes this one way you can convert things in black and white.
Yeah, it's interesting. There's still a lot of journals that don't accept color images. So even though like color printers are pretty common and people often just read PDFs, they'll either charge you extra for color images or they won't like it at all. Or they'll make a compromise and say like, well, you can submit color images and those will be the ones that show up in like the online version. But you should try to design them so that they look good in black and white in case somebody needs to photocopy them or print them. So still good to pay attention to making good black and white figures.
Well, what was it last week?
Okay.
This morning I continued working on the RTK post.
Okay. Go ahead and hit pause there. Okay. Time for the July 20th lab report. Oops, there we go. All right, so a lot of the work that I've been doing over the past couple of weeks has been the REU. So Andrea is presenting a lot of the stuff that we're doing together there. I wanted to present some of the other stuff that kind of pops up. One was I found a pretty nice, it's a little dated, it's from 2016, but it's still a nice article sort of talking about how to get a good 3D model out of your flights. So I would highly recommend it. They did it on some like dorms for naval officers or something like that. But they basically made a couple of good points, which is the time that you fly is important. So ideally we'd like to fly when there's going to be the fewest shadows. So noon is a good time, but overcast is also a good time to fly. Capturing nadir imagery, so when the camera is pointed directly down, is often the best kind of first pass for this stuff. When we flew in Mexico, we did not fly with a gimbal, and so there are some shots where the camera is sort of a little off nadir. That doesn't matter too much, except for that some of them have captured the horizon. But I just noticed in Pix4D that there's a way to just carve out the horizon from an image. So you can go back in and say, this section of the image is horizon, that section is horizon. When Earl showed us this stuff yesterday or the day before, we were just removing them off of the stack.
Yeah, that's what I did.
But I think that there's a way that you can still use, 90% of the image that's still good. So I'll play around with that and get back to you guys. It also recommended sort of circling the structure to capture oblique imagery. It made the point to try to avoid capturing the horizon. And it said to fly, this is interesting, because it said to fly at the same height as one of your nadir images. I don't really know why that's important. So you can see that one of the nadir images was captured at 150. And then this set of oblique images at 45 degrees was also captured at 150. I don't really know why that's important. But in the article, they've got sort of images sort of showing just a nadir reconstruction, and then the ones that include the oblique. And it's substantially better with the oblique stuff. So yeah, if you guys need a reference, this was a good article. One of the projects that I've been working on for the past couple of years is using the LiDAR to capture imagery. So LiDAR here is, we're shooting lasers out and we're reconstructing the environment based on an active sensor. So we're shooting it out, seeing when it comes back, and we're using that to reconstruct the environment. We're using this Velodyne LiDAR to do that. We've had a lot of trouble. We can capture the data, but turning it into a point cloud like this is difficult. And so we've always been kind of on the lookout for new software that's going to do that. The problem is basically that this software is extremely commercially valuable, and so people don't release it open source very often. But this was a new one that I just saw coming out, and it seems to be based on the company or the guy that kind of then spawned a company that did a lot of the reconstructions that we have done. So Earl went around a couple of years ago with a LiDAR on a backpack, scanned a bunch of stuff, and then this company was nice enough to kind of process the data using their algorithm. And this seems to be a direct descendant of that algorithm. So that's nice, because that guy had published it open source and then like took it back again, deleted everything online, and I haven't been able to find a copy of it, but he had a copy of it and used it to kind of regenerate a new one, so at some point we'll look to that. This was big news, kind of old news, but I don't think we've reported on it at a lab meeting. But we did get the machine set up in my office for remote access. So
That was really nice.
great, I'm glad to hear it. This is actually really cool, Andrea, and if we had more time, you could process some of your data this way, although I think the laptop is going to be the easiest way. But you can basically connect to a machine as if you were right there. And so it's a really handy way of accessing a computer, whether it's like a work machine that you need or a research machine that has a little more power. So we set this up, and they can remote in. Macs can do it to a Windows machine. Yeah, it can open up so many different options. So yeah, it's awesome. So probably Sammy will tell us a little bit about how he used it over the last week or two. So it's all set up. We did figure out that it essentially drops a wireless connection. So if we had the server plugged in via wireless, if you tried to RDP in, it would drop the wireless connection, and then you couldn't establish the remote connection. So it basically just didn't ever work. So we had to connect it to a hard Ethernet line, which is why it's in my office now. We did put an order in yesterday, or we got approval yesterday to get the ITS line in here active. But they gave us said it's going to be up to 4 weeks before they can get it done. So pretty slow turnaround, but at least the machine will be back in here. I'm here again until I'm probably moving August 6th. So that's my last day around DeKalb. But Earl should have the space, so you should still be able to come in here and use machines and do whatever you want to do. We also set up a Slack channel. I actually set it up quite a long time ago, but I'm making a push to get people using it a little bit more often. This is just kind of a website, or a website, sort of like a chat room essentially, and you can access it via an app on your phone or on a web page. Hopefully, just kind of like a group channel. We've been using it now sort of for about a week. Have you guys found it to be? I know we still haven't used it for a lot yet, but
I can see the potential for it to be more like efficient than email because everybody can see it. It's kind of like less formal than email, so I think it makes, if you just need to communicate something really brief, it's easy to do it.
Yeah, I think, and if we have channels, right now we only have general and random, but I thought we might make channels for particular projects, so whether it's like drones or LiDAR or whatever, and then people can kind of use those rooms, but they're available to everybody in the group, but people may not tune into them if they don't care. One of the big challenges for the project it was and is sort of making assessments of how good our method was. So essentially what we did was we would go down, we would set up 2 RTK units, either both of them on land or one of them on land and one of them on water, and then fly the drone and then use that point to generate like a ground control point for the Pix4D reconstruction. We're not actually using it as a ground control point. I'm going to try to do a post correction and cloud compare. So do the reconstruction without ground control points in Pix4D, and then just attach it to a point that we know.
Move the entire cloud.
Yes, exactly. So that if that works, we would only need one single point. All you would need is a single RTK GPS unit. You'd go to the field, you'd set it up. As long as that was in the image somewhere, that should be good enough to do the reconstruction. But we need to test the accuracy. So we've been putting it on these monuments. This is one of the monuments that we found in Leona Vicario. We didn't get to fly this one, but that's why we're flying the one by the lagoon. There's another one just north. We'll talk about a mission that I have planned for you guys for Monday or Tuesday, where I'm hoping we can do the RTK on this unit, fly it, move, do an RTK unit over there by the other landmark, do a single correction over here, but then see how it held up for that correction over there. And we should be able to make a nice certain comparison of how good these things This was kind of interesting, and I only mention it because it came up for me, and I never found this page. I subscribe on Facebook to the Cube Autopilot group. There's all kinds of great stuff that comes across as sort of like a chat room. People post these questions, and pretty knowledgeable user base will pipe up. So it's a really nice casual way of sort of getting this information. This issue this is an octocopter with the propellers mounted on the top and the bottom. In this case, he had one propeller that wasn't turning with the rest. So if he would arm it, 7 of the propellers would spin, but that one wouldn't. And it would spin if you gave it throttle, but not at normal speeds. And so I had this exact problem, calibrated the ESCs like 50 times because I thought that was going to do it. But there's actually a way to set the motor range when you're setting this stuff up, and it was pretty easy, and just one of those little tidbits of knowledge that, like, if you don't know, then you have no idea that it's there. So just a note to the group, if we're continuing to build stuff, that was
The motors had different ranges set in them.
they shouldn't, but slight differences in one made that one. They call it like a dead zone, and so you just need to set that threshold up by 1% or something like that, and then that's enough to get them all spinning together. And this didn't even really have any effect on the flight. Like, it would fly fine, and ours would fly fine, and eventually this went away on ours, and for no reason. So yeah, who knows? Okay, this next week, so for this project that I'm working on with Andrea, what we're trying to do is make a comparison between the drone stuff that we get and the RTK GPS measurements and the satellite measurements, so SRTM and ASTER. So that'll have direct benefit for you, I think, kind of really quantifying what the error values turn out to be. That's also going to get me moving on the water filling algorithm that you need. So I've got a good reason to focus on that. There's so one of the things when we were looking at this was an assessment of how accurate SRTM data is anyway. So there were some studies that we looked at before we left for Mexico that had sort of like, we took the 7,000 benchmarks in the United States and we ran them against the SRTM data, and here was our error values, and that's how we know what the error value of our SRTM data set is. But I got to thinking, so I worked with Waldo Tobler at Santa Barbara, and one of his interpolation schemes for geographic data was called pycnophylactic allocation. And the idea is it's a sort of iterative process that takes sort of an average in a raster, but then reallocates based on what the surrounding pixels are. So it's a way of interpolating or guessing the values at different points, because if you've got a 30-meter grid cell and your point is here, you don't necessarily want to use whatever that center value was, right? Because this might be, let's say, 8.2 meters, and maybe this is 10 meters, and the pixel boundary is here, and your benchmark is there. Well, you know that it's going to be higher than 8.2. So you have to interpolate this, and there are a number of different ways of doing that. But pycnophylactic interpolation is generally a lot better, I think, at doing that than some of the other methods. It's getting kind of up there. But the point is that I've been really itching for a chance to implement a pycnophylactic interpolation for something. This is an ideal application of it. I don't think it's ever been done before. So should be make for a good, if we write a paper off of this is the kind of thing that's really going to add a lot of value to that paper, I think. So, and have a lot of benefits. If it works the way I think it's going to work, it's going to make SRTM data more valuable for more kinds of elevation. If it can reduce the error by 10%, 20%, that could really help. So.
I had a friend who he contoured the SRTM data.
Oh yeah.
He used the points in between the contours to doing it that way.
Okay. Yeah, that would be one way to do it. Yeah, there's a number of different resampling algorithms within ArcGIS that you can use to do it, or you can interpolate it directly off of I'll probably have something about that next week.
Are you guys putting are you getting RTK corrections for the drone? So like, are you tagging each picture with RTK corrected coordinates?
No, that's a good question. If we had had more time, we would have done that. So we actually bought the RTK here, GPS, which is on the drone. We've got the correction unit. The problem is that I didn't have enough time to figure out a great way of sending the corrections to the unit. So no. And one thing that we could do that I really wanted to do and I didn't is with an RTK unit on the drone itself, we can be logging the GPS position of it, like the full data set. Like you've used a reach, right? So
yeah,
we could be logging all of that data and then post-process it the same way we're post-processing what you're doing.
yeah.
So we wouldn't have to send live corrections, which we don't really care about. We could feed it the corrections, and then that would be better.
Yeah,
So,
'cause looking for the future for me, if like I were to take a next step to try to improve the accuracy of what I got, I think the way to do it is to have the geotagged, the images geotagged with RTK corrected coordinates.
yeah. I totally agree. Yeah. Although I would say that I think that the performance of the moving RTK platform was not as high as I had expected it to be. So that was interesting. And we're using so yeah, just one base talking to one rover produces really nice relative gains in positioning, but the absolute gains, that's why we're having trouble, is because we need that absolute value to be totally right. You probably do too. That vertical elevation has to be pretty totally right.
So you can compare it to other people's data.
Yeah. So yeah, we'll keep the conversation rolling, because I think so that's one of the nice things about putting an RTK unit in a fixed position during the whole flight and then being able to kind of reference it back. Is it's a static position that's going to diminish that error a lot. And as long as your cloud is metrically correct and you can recenter it, then the whole thing is done.
How long have you been putting it in a static position before you get a good?
We did some tests. They really do. So they recommend 15 minutes as a minimum, and you can see that 15-minute mark in the data. Like it really does start to converge at that point. We've been trying to hold out for 30 minutes just to kind of, and then often our missions are even longer than that. So if we flew 4 missions from a single site, we might be there for 2 hours, in between missions and setting everything up. So that's a nice long data set. That I can't remember where I saw it, but that seems to be another marker. So there's a rapid fix that's between 15 minutes and 2 hours, and then that 2 hour to 48 hour is another window of what it takes to get like the next level of accuracy. Oh, like at the well field? Yeah, the monkey could steal it. We actually had a monkey steal our RTK unit. We got it back, but it was right over one of the cenotes, so we had it in this Tupperware to float it on the surface of the water. So he goes down and picks up the Tupperware and opens it up and takes the thing out.
Oh
And
my goodness.
field work. All right.
All right, so this is my lab report for July 20th. Okay, so what I've been working on is, well, I finished all the processing for all of my surveys on Earl's server. All 8 of the surveys, which on average, each of them took about 6 to 12 hours to process. And I found a new way to process that, which I will talk about, that removed the warping from that. I've also been working on making maps of my study site in Adobe Illustrator for my thesis. Yeah. So this is an example of a map from Illustrator that I made a few days ago. I just used a Google Earth image and then traced over it. And I wanted to make all my maps in black and white so that they're easier for people to print, and then also more acceptable for if I can ever get this published.
That looks great, Timmy.
Thanks. It took a long time, but yeah, it was fun. So I figured out why I was getting so much warping. The geotags were actually, there's some kind of error going on with the GPS, where like I was getting altitudes that were way off of where I knew the plane was. The plane didn't crash. There were some times during the flight where the GPS said that the altitude was 0, and you'd expect that the flight algorithm would tell the plane to like go up to avoid hitting the ground, but it didn't crash, and I believe that's because it uses multiple instruments for flight. So I guess it's the barometer, the altitude it was getting from the barometer canceled out the GPS error. So while the plane is flying, I think that it's staying pretty close to 110 meters, even if the GPS is off, because it's using other instruments to compensate for the GPS error. This is the raw altitude data for the images, and you can see it says like 42 million meter altitude.
Is that like the moon?
Yeah. And yeah.
So this is awesome because we've got reporting here of not just these data, but horizontal accuracy and the vertical accuracy. And you'll notice that while these are absurd, the reported vertical accuracy is still 10 meters, right?
Yeah.
So you can never trust those numbers to really know, right?
No. And I didn't see this because until I sorted the images by like greatest to least in altitude, and I didn't really think of doing that until like a few weeks ago.
How'd you come up with the idea? Like, what made you think to look for that?
I was just looking through the data just like randomly, and I just noticed this. I wasn't really looking for it. I just kind of came across it, you know. And then the other thing is this is the same flight. There were really low altitudes at like 0.5 meter, 1.5 meters. So
what GPS were you using for this?
It's the one that came with the Pixhawk Autopilot. It's actually a 3DR brand.
Oh yeah.
So the other thing I did, just to be safe, is I increased the vertical accuracy to 20 meters, just to give a little bit more room for the processing.
So that's not an assessment of accuracy from the unit itself, like vertical dilution of precision. That's a tolerance value that you're providing to Pix4D.
Yes. Yeah. I believe, this is just a default that Pix4D puts in there.
Okay. All right.
And yeah, I just chose 20 meters just because I didn't trust the altitude as much, knowing that it had so much error in it. So this is an example of the two DSMs. This is before the correction, and you can totally see this area is way higher than the rest, and then here it's all flat the way that it should be.
So he was getting these problems where the whole two different problems. So one, the whole surface was warped,
Yep.
and then in this case it's tilted because you can see that upper left-hand corner is high, the lower right-hand corner is low. So the whole thing is like taking a flat plane and kind of tilting it that way, which is not how it really is.
So the long story short, I was able to remove the tilting and warping by setting the altitude for all the images to 110 meters. I also, so I was able to do rapid processing on all of my surveys and full processing, trying to compare to see if there's that much of a difference in what I'm getting. I did the processing using rapid settings on my MacBook, and this is just an example of the how much time it took to process. The longest one took 8 hours, and the shortest one was only 3 hours. So it was manageable to process surveys that were like 1 square kilometer to 2 square kilometers on my laptop.
So is this just step one or all of them?
This is, yeah, all 3 steps.
So the rapid settings, where is that specified again?
When you're opening the project in like the opening dialog,
Okay.
you can choose like full or rapid. And there's also like options for if you're making a model versus making a map.
Did we ever figure out if there's a real difference between making a model and making a map?
I emailed Pix4D and they told me not to use the model one for maps.
Okay.
So I'm guessing there is.
All right. So just maps from here on out.
Yeah. So I have a friend in Cambodia who actually has a Reach RS, which is the like it's the bigger like survey equipment style version of the Reach RTK unit, and so he has 2 of those, and he went out and took measurements of the elevation in points where I flew my survey, so I was able to compare the elevation of these points from his unit, which should be accurate, pretty accurate, definitely accurate, more accurate than what I flew. The manufacturer says it's less than 10 centimeters, and then in his data it also tells you whether it's a float RTK solution or a fix. So all these points were fixed RTK solution. One thing that I'm not totally sure about is the Pix4D DSM. The vertical datum is EGM96.
Yeah. So I looked into that a little bit.
Yeah.
So there are 2 places where you can specify the vertical datum. So you can specify the input and the output.
Okay.
And basically it's going to do the translation, but it's going to assume that they're both EGM96. By default, it's EGM96 on the input and EGM, which means it's untouched. So whatever the input actually was
Okay.
is going to be in the output as long as you didn't change anything.
Really?
Yeah.
Okay.
So that would probably explain what's going on. I mean, if you're consistently off by that margin,
Yeah.
maybe you've got a difference between like the ellipsoid. Maybe that's just an ellipsoid geoid height difference.
Huh.
Maybe.
Okay. So
But it looks like the pattern that we're getting in the Yucatan.
okay, cool. So the GPS is referenced to the ellipsoid.
Right.
So you're saying that the output that you're getting in Pix4D isn't going to be changed.
Right.
So it's
Whatever the
gonna be
input was.
references.
Yeah.
Okay.
Yeah, it's a little confusing, but I did verify that with like 3 different. I did like A to A to B, B to A, B to B, and did the comparison. And yeah, if it's A to A, then it's
Okay.
Yeah.
I would guess guessing that his units are going to be referenced to the same thing.
The ellipsoid. Yeah,
Yeah.
I would think so too.
Huh.
But that's not necessarily true because there are settings and there is an easy switch within the processing that it'll do the correction. So yeah, you'd have to dig into how he processed the data to
Okay.
know exactly.
Yeah. All right.
Cool. How to get a Recharge RS? That's great.
Yeah.
You just had one laying around, or
He's using it for his research.
that's the nicer version of what we're using. So we're using the Kickstarter early version, and then that's the production version.
It's like waterproof, and
Oh.
Yeah.
you drop it on the ground. So these are just the points that he went out and took measurements for me. So just to conclude, I thought that everything was referenced to EGM 96, but it sounds like things are actually referenced to the ellipsoid. There's like a difference that seems to be kind of stable between the Pix4D, DSM, and the survey points from the reach. So that suggests that they're referenced to different datums. So I guess just look into that a little bit more. And then in the future, part of my processing workflow will definitely be to check the elevation that I'm getting from the GPS before I actually process things.
Yeah, do that. So in Pix4D, when you bring them in, you could just sort by that and get a